Bridge nav. 30 meters at 315. All right, we're starting to overshoot. We're about completing this step.
Nah, it's
I know, yeah, I
the
see it.
gritter is choking a little bit, but that's fine. Yeah, the data's not lost. I set the resolution a little too high on the gritter, so it's like,
What are we saying there, Jeff?
I'm saying the vessel's
it's
passing in. We're going to push Herc 30 meters up here, and I maybe push him a little bit more when I see us get past the target.
Yes. Oh, yeah. Keep stepping in, yeah. I have, Chris, if you're listening back there, I got 82 meters left on this move. Is that accurate? We're going to let it stop there?
yeah, I think that'll be okay.
Okay.
We're trying to limit what we're doing here so we don't take forever.
Yeah.
Maybe we saw something back here, but it's hard to, it's hard to tell. We didn't, there it is. But like, it's kind of over the edge, and I don't know. It could have been something on the bottom, kind of floaty, or we didn't see anything in the water column that looked interesting, so.
Tammy,
Yep.
any chance you can take that and put it on the Herc one up there and give us back the big Argus view?
Absolutely.
How much more you have on this
I got
step?
64 meters.
Hang out 2 meters.
If we have time.
Bridge nav. 30 meters at 305.
Hang out 2 meters.
Roger.
Okay, Chris, talk to us about the Norbit. Is the Norbit did you name it this? Or is that a brand name?
That is a brand name. It is a multi-beam sonar, which does this. So you can see here. I guess this is out on the quad now. Can any people?
Yes, they
Okay.
are.
So this is the raw sonar coming in. You can sort of see this line here is the echo from the bottom. So we take this image and we find the points where they occur, or where we think the bottom is there. We plot those, and then we reference those relative to Hercules, which you can see here. We reference those relative to Hercules, and once we know where they are relative to Hercules, we know where Hercules is in the world. We plot where Hercules is, and then we keep track of where the points project into the world, and we can make a map.
And how detailed will that map be?
This map will be maybe 25 centimeter resolution.
Yeah, we're laid back a bit.
Something
you
like
can
that.
try stopping them. I think we'll be okay. Yeah, we're just 23 meters out. Yeah.
That's wild. That's amazing. Do we have to keep Hercules at the same elevation?
We try to keep Hercules at the same altitude above the ground, so that gives us a constant swath width. The higher we go, the farther out we can see, but the lower resolution.
How did you decide the altitude we're at? Like, is that a specific calculation?
Say again, sorry.
How do you decide on the altitude, or do you just?
So
is it a specific, or do you
it's
pick
mostly
one?
a matter of time constraints, and for this dive anyway. So we had a 400 by 300 meter area. I figured so I wanted to do it in 3 passes.
Come to all stop, please.
So I wanted 100-meter swath off to either side. So you just do a little bit. You know how wide the swath is in angles, and you do a little bit of trig, and you figure out how high you need to be to get that amount of coverage.
You're making a lot of math teachers very happy right now. So 300 by 400 is the total area?
Yes. So it's 400 meters long. That's about the length of the line that we just did. And it's 300 meters wide, so.
We are just at the end of the line here. We got 8 meters left to go.
Yeah.
Did this multi-beam need any modifications to be able to work on Hercules?
No, well, it didn't need any physical modifications, but it did need a lot of custom software in order to work. Yeah, the multi-beam itself is kind of just plug and play, yeah? Plug it in to the give it power, and you plug it into the network, and you can hear from it, but that's only half the battle. The other half is figuring out where Hercules is in the world. So
that's what Chris does.
That's what I do.
Okay, that's the end of the line there, Chris.
Okay, so yeah, let's go over to the next line then.
How far?
Okay, so you've got the ship stopped up. So yeah, how far away is this line?
100 meters.
Okay.
I'm going to make a 100-meter step. Bridge nav. 100 meter step at 330.
Hey, Mike, while we're waiting on that step, I'm wondering if you know what happened to our CTD sensor.
Can't hear you very well there, Nicole.
Sorry, the salinity sensor is not reporting data.
Okay, I'll have a look.
Do you see it up there at all?
Just a second here now. You mean the CTD?
Yeah, I see water temp, but I don't see salinity.
I've got it at, I've got everything reporting here. It looks like it's good comms. I've got salinity at 34.52.
Okay, so it's on our side, but we're having a Data.
And it's reporting temperature and
issue.
depth and speed of sound.
Okay.
So did you do you got the vessel at
Vessel's making that move,
yeah.
100 meters to 330, so it's pretty much going that.
Did you call it in at 330 though, right? He was going to go over there.
Yeah, you have your,
I'm backwards.
Yeah, you're 90 out or something like that.
should be about 045,
Bridge nav,
right?
I'll stop.
Something like that, yeah.
Got a angle issue. Let's give him 2025. Bridge nav, 100 meters at 030.
Might be.
Yeah, I got it. Let's sort it out. We have quite an offset on here. Yeah. Okay. I can do it. Get it on. Let's do it now. DVL reset.
As we're sorting out this corner, Chris, how fast is Herc moving as you're mapping?
Half a knot. Very slow, but as fast as we can go. Yeah.
Half a knot is 1/4 meter per second. So think about taking like a very small step, you know, not quite 1 foot in front of the other heel toe, once per second. That's about how fast we're going.
Yeah, keep bringing your heading around, right, to closer to 45 degrees. That's the direction we're going in. Where's the, show me the ship. Okay. Yeah, we're gonna have to wait a couple of minutes for the layback too. It's pretty significant.
I'll give him an all stop when we complete this move in 30 meters. Is that enough? Or do we want to?
Yeah, we're gonna, well, once we all get going and stuff, like we're gonna be about the same distance away as the ship is. So I would say take the ship the full 100 meters off that line like you did, I think, right?
Yeah.
And then, yeah, when we settle out, we'll be there.
Okay. Hey, Chris.
Yeah.
How many beams does an orbit have?
Lots. Let me double check. It's kind of, I think we get 512 generally out of this one. But it kind of depends on your setting. Yeah.
Yeah, so 500 beams.
Yeah.
And what's our ping rate? How many times are we?
At this altitude, it's about 6 hertz.
6 hertz, so 6 pings a second.
Yeah, 6 to 8. Depending on how far the farthest thing is, it adjusts automatically. Although I might just limit it to 5 because we're getting tons of overkill at the speeds we're going.
Handy dandy calculator over here. It's like every minute we're generating somewhere around 180,000 points.
Yeah, I'm familiar with this problem.
To those listening at home, that's a lot.
Yeah.
But you need that kind of density
So each
to
yeah,
make those
right.
high resolution maps.
Each point has an XYZ, which is what, 2 bytes. A floating point XYZ, 2 bytes for each. So
2, 4, 8, 2, 4, 6. Now these are going to be pretty large files, aren't they?
yeah, and that's not including the water column, which is many more than that.
Yeah, I'm well aware of that one.
Yeah. We're, I don't know, what are we at? I can check. We're up to 5 gigabytes for that one line, so. Which isn't actually terrible.
No.
It doesn't sound too hard. Yeah.
Hard drives are cheap.
And that's all the nav and everything else too, which the nav runs at 100 hertz.
Ooh.
So
yeah.
That, even though it's not a whole lot of data running at that rate, it does add up.
We are going to the vessel hold.
Yeah, if he's at 100 meters away, like hold, and then the Argus will fall back in place here, and we'll get going.
Can you
nav all stop?
Can you drop a target where the start of the next line is going to be, where you measure it?
Roger.
Just give me an idea. Oh, that looks, yeah. That'll be good.
Putting up. 2
Roger.
meters.
You see that, Chris? It's 100 meters off our previous track.
Yeah, I see it. Thank you. That's pretty good.
We're going to that waypoint 4. Is that the one you just put in?
I just put this
or
one.
This one. Okay.
That's offset 100 meters from
Yeah.
our ending point.
Okay.
Yeah, this looks like a good spot to start right about here.
Okay. Does that look like we'll go right through your waypoint? At what it will be 220 or 125 bearing, I think.
It'll be 125, 126, and we're still a little bit out.
Look shy.
Yeah, we're not at that angle yet.
Yeah, let's just go ahead and start here. This looks like a good, and as far as coverage is concerned, this seems like a good spot, so.
Okay, I'll
Roger.
take up the heading and then just give Argus a second or two to see if he wants to settle in any better.
Do you just want a long vessel step, or do you want to?
Yeah, one long vessel step. That's what we did last time.
They're
That
stopped
worked
there
great.
now, are they?
We're stopped now, waiting on a new move. So you ready for vessel to start moving, or you want to get?
No, give us 5 minutes here to see where Argus goes.
Roger.
As the vessel stopped? Or
Vessel
stop, but see, Argus is still swinging,
swing.
right?
Yeah, it's swinging.
Just give it a minute.
What is our altitude right now?
30 meters.
30 meters. Okay, good. Perfect. I might have you increase, well, we'll see when we get closer, but I might have you increase altitude a bit once we get to this hump up here.
Okay, yeah.
Just because, yeah, that ended up being pretty shallow relative to our last pass, because we were altitude holding over this bit.
Right.
So we might have to step up to make sure we get the coverage, but we'll check that when we get there.
Roger. Does her position look good right now?
Yes.
Yes. Okay. Okay, Randy, start bringing your heading around a little bit.
Roger.
Eventually, it should be on 125.
Roger.
If we're somewhere near there, and they're not going to line up perfectly, but they look like they're going to be close enough.
Yeah.
I wasn't able to get this monitor. I was trying to get set up over there with one as a display, but this actually works pretty good because I need to come over here and check this out periodically. Yeah, this guy is, I'm trying to be nice to this computer because it's the one doing all the data logging. So we can brutalize Norbit laptop all we want without risk to the data.
Let's keep them in the frame.
Yeah, roger.
You guys can start whenever, just let me know when you do.
Roger. Yeah, I'm just going to give it another couple of minutes, Chris. Argus is just getting back where it's
perfect.
Where it's supposed to go.
Does that look good, Mike? Or you want me to?
Yeah. Look at the Herc line. Just it did auto altitude for sure.
Yeah.
You can see the little red Herc line. Yeah, it's hard to see. Ugh. There it is. Yeah, just tracing the terrain.
Okay. Let's just, he's close enough. When we go, he'll just fall in.
DVL reset before we go?
Yeah, if you like, yeah. Go ahead.
Roger.
Good.
Yeah, he said earlier that DVL resets aren't impacting him at all.
DVL resets are fine, yeah.
Like, I held off on doing one, but it's still it's bang on, I think. Let's get one before we go.
Let me add.
I did not do a DVL reset, but I'd like to.
Okay, go ahead.
All right, we're reset. We're going to make vessels.
Okay, so we're ready.
Bridge nav, 400 meters at 125.
There we go.
Some nice overlap.
Yeah, that's what we were hoping for.
Yes.
Yeah, it looks like there's a lot here, but some of these outer beams get a little weak, so.
Were those just rendering gaps along the line?
Yeah, the gritter is struggling to keep up a little bit, so. I turned some things down, so
Yeah.
maybe.
Just see the ship a bit so I can tell when they're actually on the move.
Are you guys marching along? Or are you waiting on things?
We're not moving yet. I'm just
Okay,
looking at
that's
the
what I
nav
thought.
screen, waiting for the vessel. So
Yeah,
the
that's-
vessel's just started moving.
Vessel is moving at 0.4, 0.5.
Roger. Okay, starting the line. We're going to take it up to 0.5 knot right away.
Yes.
That's what we got in here.
Mm-hmm.
Okay.
Is that what you set the ship for?
Yes, they are moving around 0.5. Mike, is this
That's
looking
Argus.
okay?
Yep.
Okay.
Yep. Say something now?
Because
Oh.
one is USBL and one is DVL. Yeah. The one with the pointer on it is the
Yeah, it's
DVL.
looking good now that we're rolling.
Uh-oh. Tim, make it better. There it goes. All right. That's quite the roll offset we have there. That's fine. I have tools for that.
You can frame up Herc a little bit better there. Just change your heading a bit.
Oh yeah. We'll go to port side, I guess, right?
Yeah.
0.5 knots.
Maybe a little more.
Can you do me a favor and stick a waypoint at the end of the track, just so we have we can keep track of the time to go?
Roger.
So Chris, from the data we're collecting right now, can you tell, like with the overlap, is the offset and everything looking good? Like, is it the data agreeing between passes?
There's a roll offset, but
There's a bit of a roll offset.
I have tools for that.
Yeah. This is the first time we're running it, so we
Yeah,
haven't really done
I
a
had no way to
patch
I had
test
no
or
way to
anything.
really calibrate it before,
Yeah.
yeah. But yeah, you can see there's a
Oh yeah.
Yeah.
significant. Norbit is so wide, it is very sensitive to
So you'll see it.
roll and yaw offsets and stuff. So, but that's, I mean, it's almost, in some ways it's nice because it gives you a big lever arm to adjust it and get it dialed in exactly.
And you would expect that once you dial that in, since it's bolted onto the vehicle, it's going to stay the same?
Uh-huh. Until Bob gets a little too excited with the crane.
Yeah, that's... Well, and one of the things we didn't mention was that there is some configuration of the Norbit because we were using it yesterday in a forward-looking configuration.
Yeah, every
so
time we move it, it's gonna be a thing.
It and,
yeah,
you know, reorient it.
Or let's pull up the water column so we can look for bubbles.
Ideally, we'll get that pan and tilt up and running if it can be resurrected at some stage, because that would be neat. That will allow us the flexibility.
That would be nice, yeah. Like today, that would have been great.
Yep. Is that bring it back to the lab on land and have someone look at
Probably.
it?
I think one of the axes is still okay. So we could, in theory, put it back together and leave one axis be dead and use the one that's good.
We really only cared about it in
Yeah,
one,
exactly.
right?
Exactly, yeah. Other than the roll offset, it looks like we're doing kind of okay. Like hills are lining up with hills. This is just dead reckoning only. This doesn't fuse the USBL, this version, so Once we fuse the USB all, that should be even better.
Video switch.
I don't want to let the world see my
Your messy
crappy Python code that I hacked together last night.
You wrote this code last night?
What? No.
This has been a
Come
work
down
in
a
progress
few
for
meters,
you. You've been working
Michael.
on this for a few
Try
years,
and hold
right?
it around 15.
Yeah, well, yeah.
Tommy coming down to 15.
And this year we basically kind of
Rewrote it.
started over.
Why was that?
Well, because we started with raw data straight from the sensors this time,
Ah,
which gives us a lot more options in terms of post-processing and things. I mean, you know, you learn lessons from the old software, so it's not a complete starting from the scratch, but
so what were the other environments you've tested this in?
Video back on.
we use this on the surface vessel and stuff. So like all the mapping and all, like a lot of this is very similar to what we use on the surface vessel.
Is it on the kayak as well as the pontoon?
It's on the kayak and the
Yeah.
pontoon and the new one and the new survey boat and why rewrite things? No, but it's really helped. Doing that has really helped with testing and getting things up to speed before I come out here.
Yeah, certainly being out.
So that way you come out here and you work on Hercules specific things and not just, you know, general programming problems. Yeah, I think definitely when we get up to that mound, we're going to have to increase altitude a little bit.
Roger. What are you thinking? Like,
What are we at now, 30?
Yeah.
Maybe, well, we'll step to 35 as we get close.
Yeah.
And I'll see if that looks like it's going to do it. And then if not, we'll go to 40, and that should definitely do it.
okay.
It might not even be an issue, but I don't want to miss out on something.
Yeah, for sure.
I'm surprised there's that much roll-offs. Well, I guess I'm not. Things were just kind of bolted on there in our best guess.
Yeah, I guess that means the whole mount is a little bit crooked.
Yeah. I mean, it's you bolted onto the frame.
Yeah.
So it's not like it was bolted to precision machined things. But that's okay. We pretty much don't expect it to be, even if it is bolted to precision machine things, we don't expect it to be perfect, and we compensate for that after the fact.
Annie, can you just shift that screen up? Thank you.
And I'm glad this is just our dinner relief. I like mapping better from the data lab from the ship. This is just waiting. Oh, I'm doing what you're doing. Waiting.
Psi 2. Oh, yeah, that hole, don't worry about that hole.
We don't talk about it.
The gritter is having a hard time keeping up. The data, we do have data though. Yeah, what you're seeing there is a gridded point cloud, not right. And yeah. we're throwing a lot of data at it, and it's a little unhappy. It is, yeah. It's about 200 meters almost. Yep. The very outer beams, if it's very flat or if you're looking down slope or something, can be kind of bad, but right now with it, especially with this like bowl shape kind of thing, yeah, it's 75 meters to either side, so, because we're in this bowl, but.
Did you guys see any bubbles?
I don't think so. We might increase altitude as we get up to this ridge, because we didn't reach very far into it on the first pass, and I just want to make sure we get the whole thing. Yeah, which I'd rather have it.
Do we have Argus zoomed in for a reason? Is it zoomed in, or are you just close? Okay. Swear.
Yeah, it was going. It's going fine. No, I'm from the. We can look at the nav here. You can see the red line. That's its trajectory. It's doing totally fine.
That's cool.
Yep. Yeah, it's very minimal at this point, but when you get tugged or something, you can definitely see it. Yeah. That many.
Woof.
Yeah, it's not terrible. A lot of this is like visualizing and all that. Everything in this Herc box is the stuff that is actually required to run the system. Everything else is, yeah, so like this is just the recorder, and which creates a lot of spaghetti. But
oh, this is cool. It's over my head, but really interesting.
yeah, it just shows how where all the data is piped around into what systems and stuff.
Wow.
Oh, we actually, oh, wait, let me double check. Are we? Norbit must have changed some config or something, because like it had a couple dropouts. So yeah, let's start bringing the vehicle up. Yeah, bring it to 35. I think that'll do it. Because we're going up the ridge too, so.
So how do you know which data set to align the rest of the data to? Because like these two are obviously like the same thing overlapping, but they're like slightly off. Like how do you know which one is the true?
Yeah, I guess, yeah. you sort of minimize the error along all of them, and you hope that on average you're doing well.
Gotcha.
Chris, are you trying to map to that waypoint? Because the ship's step ends in 37 meters.
Yeah, we're trying to map to the waypoint. He must have not entered enough.
Okay, I'm going to extend it.
Yeah.
Bridge nav. Can you please extend this step 200 meters? Yeah, so 2-3 meters at 122. 2-3 meters at 122, please. Yes, please.
We're going to cheat a little bit too.
Sorry, bridge, 230 meters at 122. Thank you.
So what's our altitude now? It's 35, okay. That looks like it's going to make it. It's still kind of close. If you could come up maybe in even another couple meters, just kind of step up as we go. Oh yeah, that's true. Maybe we shouldn't go up too much more.
Video swapping out.
We might have slid over because actually this feature here looks like it might be that one. So we might actually be doing better on overlap than we thought. Oh, see, no, we're doing fine. We got it. It's below the other, the points are coming in below the other one. See, so it's coming all the way over here. We got plenty, no need. Yeah. Yeah, we just have some misalignment. This solution is dead rec only. It doesn't work. Hold on a second. I got something. For some reason, we just lost the bottom. Let's do that. $1,200 or something? Is that right?